This is the first time I get to follow Andy, and I want to do it again. So maybe we'll run through this a couple of times. Building on what he said, I have a few prepared comments before we get into a little bit of data. You know, I think I've been to almost all of these conferences. I just realized that. And I think they get better and better as the years go on. So good for us. So I'm going to report on the health of the intertidal habitats of the bay. These are the tidal flats and the marshes that are subject to the daily ebb and flow of the tides. And in so doing, I'm going to illustrate one possible approach to ecological health assessment. The intertidal habitats are not the only habitats addressed in the State of the Bay report, of course. There are also sections on the waters of the bay and the life they should support. And there are sections on streams and wetlands and riparian areas in our local watersheds. The connection between the watersheds and the bay, I think, is going to be especially important as we go forward from this report to the next one. All of us encourage ourselves, we here as co-authors encourage you all to read the full report. A variety of other talks about habitats are scheduled for today and tomorrow that will get into important subjects and the details that I can't cover this morning. Along with the report, there is a brochure produced by SFEI that is available, I believe, in the back of the room or out in the lobby there, that characterizes the landscapes of the bay and how they have changed over time. In many regards, with this talk this morning, I'm just opening the subject of habitat health that will be addressed throughout the conference by many other speakers. There are many terms relating to ecological health that are increasingly common in scientific and popular discussions about the relationship between people and the environment. I'm reading technical material, I'm reading popular material, I'm reading policy material, I'm listening to the conversation, and I'm hearing these words more and more often. They represent very large ideas that are not always very well defined. I can't count the number of times I've been in discussions about these terms, and pretty sure all of us in those discussions had different ideas in our head as to what these terms mean. They seem to be a matter of culture and not just science, and yet they involve principles and concepts of environmental science that draw we scientists into the discussions. We can't seem to get away from these terms. Now, as a scientist and an author of the report, I have to tell you, I struggled with the concept of ecological health, and for some time now I've had some concerns about what this means in terms of science. I came to the conclusion, with considerable help from my colleagues, that while I believe ecosystems and their component habitats have intrinsic integrity, I sort of know it when I see it. I know when something is healthy when I see it. I get into a wetland of some kind and say, this is a nice wetland. I understand what integrity means, at least sort of somehow intuitively. Their health is a matter of human interest. The health of the environment might be defined by the levels of needed services, as Andy was bringing up, that the environment provides. This is a practical definition, and I emphasize that. This is a practical definition that leads us to measure the health of the bay relative to the various goals, thresholds, benchmarks, and statutory standards that have been set for the bay. In other words, in simple terms, we can assess the health of the bay relative to the way we have said it should be. The result is an accounting for our investment in the bay's health. Now I'm going to get into some of the few data. If I can get this to work. As Andy mentioned, there are many possible attributes and indicators of health that we looked at as possible inclusions in the report. We also had very strict criteria as to which of these data sets we were able to use. One of the criteria was that they had to be abundantly available. Another was that they had to be QA/QC'd. Another was that the people who developed the data had to be accessible to us so we could talk to them about the data. And another very important criterion was that there had to be goals of some kind associated with the data. That is, the data could be used to track progress toward the goals, or if the goals had not been adopted by government, then at least they could be inferred by public documents. And we winnowed through all the available indicators for various attributes of intertidal habitat health. We came up with these few that met all those criteria. And I'll step through them now. No, there's one more. So they sit in the tidal marsh health. Now, this may be an angle of the bay that you're not quite used to. It's fun to rotate things down around a little bit, and so you have to look at them a little differently. It's still San Francisco Bay. And I'll bet you can find the Golden Gate. These color patches are individual tidal marshes. We measured the size of them and their shape, both historically, presently, and we forecasted what they might be in the future. We measured these in terms of thousands of acres. Historically, we had about 200,000 acres of tidal marsh. By the year 2000, we'd lost almost all of that. We're down to just a meager 40,000 acres. The good news is that we're gaining them back. Since 2000, we have increased the acreage of tidal marsh in the bay by about 10,000 acres, or back to about 50,000 acres. The goal we use for this indicator is the tidal marsh acreage goals that were established by the Baylands Habitat Goals Report back in 1999. It said, for this place to be healthy, we need about 100,000 acres of tidal marsh. That's about half as much as we used to have, and we're about halfway towards that goal of 50,000 acres, about halfway towards 100,000 acres. The future is very uncertain for tidal marsh because of climate change and sea level rise and changes in the availability of sediment upon which the marshes depend. We don't know how many marshes we're going to have in the year 2100 or even after that. We could have more or we could have less. We think we're going to have more. Why? Because marshes have some place to go. It is possible that the marshes with sea level rise can move upstream and inland in those parts of our local watersheds where we allow them to. It may not be necessary to change our goals because of climate change. It may be necessary to change the way we achieve our goals. One slogan going forward may be something like, make way for the bay, because it's trying to find some place to go. And I remember when the big issue was the bay getting smaller, save the bay from being filled. The new challenge is to make way for the bay. We can do the same kinds of analysis now for tidal flats. The acreage values aren't as great. We had about 50,000 acres historically. We have about 30,000 acres now. And we've lost a little bit, and that's because of the conversion of some tidal flats to tidal marsh, in part because of invasive species. But also what's happened is we've opened up some areas in the year 2000 for tidal marsh restoration, and they start out as tidal flats. And so we have a gain in tidal flats around the year 2000, and now those areas are evolving into marsh, and so we're seeing some of that tidal flat become marsh. Not necessarily a bad thing. The goal for this is the amount of tidal flat that existed at the time of the state's no net loss policy, which was enacted, I think, in 1993, 1994. So how much tidal flat we had at that time, we've adopted as the goal. As Andy said, these goals can change, but this is the goal that we use for assessing progress towards improved tidal flat condition. And we're about 90% of the way towards that goal. Again, as with tidal marsh, the future for tidal flats is very uncertain for many of the same reasons. Especially as sea level rises and the bay rises, the depth of the bay may increase, the wave energy may increase, the propensity of the bay to erode its margins may increase. These are the kinds of things, along with tidal marsh survival, that many of the people in the room here today will be talking about today and tomorrow. So we can look to them for some better idea of what the future holds for tidal marshes and tidal flats. The size of the tidal marsh, as we saw before, can be looked at in some detail using historical maps and modern maps. On the left, you see a part of Sassoon, the northern part of Sassoon as it existed in the year 1800. On the right, you see what it looks like now. These are pictures of tidal marsh. We've gotten smaller pieces of marsh that are farther apart from each other. This is termed fragmentation of the habitat, which is not real good for the ecological services that the habitat is supposed to survive. One way to look at size of marsh is to look at the distribution of the marshes among size classes. They're not all the same size. Size classes across the bottom, if you can't see it, the smallest size class is 1 acre to 100 acres, and the largest is greater than 5,000 acres. And so we can see how the historical marshes fit into these size classes and how the modern marshes fit into these size classes. And what we see is that historically, there were lots of very small marshes. This is an interesting finding. We think that the marshes have all gotten smaller and they used to be all larger. Not so. Because of the physiography of the land, because of the topography of the land, there used to be a lot of small pocket marshes. But there also used to be some very large marshes, over 5,000 acres in size. We still have a lot of small marshes, We don't have any of the very large marshes. Now, what we looked at as a goal for this attribute was the distribution of marshes among these size classes, assuming that the historical distribution was a reasonable goal. This is quite independent from the measure of the extent of marshes. This is the distribution of marshes among size classes, regardless of how many marshes there are overall. We think that historical distribution was important for the species of wildlife that grew up here, evolved here, or have been inhabiting this estuary for the last few thousand years. They've made some sense out of that distribution of marshes, and they're looking for something similar to that, or if it were available to them, they'd be better off. That's a very large assumption, but I want to be transparent about all of that. We can then measure the departure from that goal for each size class. And here we're saying that, well, zero departure would be really good, but because of the uncertainties in the measurement of marsh size, we're saying, hey, plus or minus 25% is okay. So if a departure from the historical distribution of marshes is within that 25% range, we say, good enough, it's met the goal. For the current situation, what we see is that for these two size classes, their current distribution, their current relative abundance in the estuary is the same as it was historically. For the larger size classes, it's not the case. We have much fewer of them than we had before relative to the small ones. So we've lost the larger size classes. In fact, the goal is met only for 2 of the 6 size classes, so we're about 33% on the way to that goal. We do the same thing for tidal flats, and the good news there is that everything was within the same relative abundance as it was historically. So we think with regard to this particular attribute, this indicator suggests that the goals are being met for all 6 size classes. Now, it's one thing to talk about the distribution and abundance of these habitats. It's another to talk about their actual physical and biological condition. For these kinds of attributes, there are lots of data in the estuary for one place or 2 places or a handful of places for 1 year or 3 years or a few years, but there are very few data that look synoptically across the whole region at the condition of the marshes in terms of their physical structure or their biological structure. And remember now, my job here this morning is to talk to you about the habitat and not the life that they support. So we're just after habitat structure here, both physical and biological. One way to look at this is with a new tool called the Rapid Assessment Method, which has a number of metrics that are used by teams in the field to actually assess the structure of marshlands and other kinds of wetlands. One way to look at those data is to plot the frequency distribution of the scores. So here, for example, is the result of an ambient, probabilistic, fancy word for better than random, survey of tidal marsh condition in the south part of the state, and then in the Central Coast, and then in San Francisco Bay, and then the North Coast. Interesting, as you go from Mexico to Oregon, condition improves overall, which is directly correlated to the number of people living along the estuaries. If you look at the median scores, you can see that these step up very nicely from the south part of the state to the north part of the state. And we have to say that the Bay is not doing quite as well as the North Coast. A reasonable goal, then, is to make ourselves more like the North Coast in terms of tidal marsh structure. When we look at those data in detail, it turns out that the thing that really differentiates us from the North Coast is one particular attribute called physical structure. The South Coast median scores and the Central Coast scores and the SFB scores are similar. The North Coast scores are much higher. And this has a couple of hundred data points involved with these analyses, and the general consensus is that they make sense and they can be interpreted. So if we want ourselves to look more like the North Coast, if that is our goal, then we're around 65% there in terms of the structure of our marshes. Now, I want to emphasize that I'm just going through a very few set of data. There are many more data that need to be looked at. There are other kinds of goals and attributes that we can consider, and I'm only talking about intertidal habitat. The report covers other kinds of habitats, but based upon these data, there are some interesting questions that we can ask. For example, does anybody need an overall health score? As Andy was saying, if somebody asks you, how's it doing, do you want to answer with a paragraph, a number, a short sentence, an elevator speech? What are we going to do? We do get these questions. If we want a single score, there is a way to do that. and that is by standardizing all the measures relative percent of their goal. So, for example, tidal marsh extent, about 50% of the way there. Tidal flat, about 90%. Tidal marsh size, 33%. Tidal flat size, about 100%. Condition is about 65%. Interestingly, we can simply, with a graphic device, report that the overall health score is about 65 based upon these attributes. That is, 65% of the health chart is green. That's one way to do this, in a transparent way. You could drive yourself through the graph to get at the data behind it and drill down into more scientific understanding and actually find out what you need to get a better score. That's a key part for us. As we were putting the report together, we said people are going to want to know what they can do to help make the thing better. What can you do to make it better? In this case, with regard to marshes, make more of them and make them bigger. That's one of the messages here, and more complex in terms of their physical structure. Well, you can weight things. Maybe they're not all equally important. Maybe tidal marsh extent matters more than tidal flat extent, and maybe their condition matters more than the others, and if you reweight these things, you get a different score. The idea is you can game the system. You can start looking ahead and say, what if we do this, or what if we do that? In fact, of course, you can add a bunch of indicators. As we said, we're pretty sure we don't have them all. We don't know what they're going to be. Maybe you people out there do. We could add them, and of course the score gets longer, and the relative importance of any one score or any one attribute decreases. So these are the kinds of things we're looking at as we move forward to the next report. Lots of work ahead. Major questions. What should be the geographic scope of the report? How much of the delta and the lands above the delta and the watersheds do we build into it? How often should the health be reported? Do we do this every year? Things aren't going to change very fast if we do that. Every few years, it takes a lot of work to put these reports together. How far do we want to give ourselves between one report and the next? Do we have all the right goals? Do we have enough goals? Probably not. What additional indicators do we need? And finally, how should they be aggregated? You can take these indicators and you can mix and match in a variety of ways. We could do this by subregion, we could do this by theme. There are many ways to put together a report of this kind, and we're going to need help knowing what to do with the next one, so it's even better than this one. Thank you very much.